It's one of the Azure messaging services for storing and retrieving large message workloads up to the total capacity of a storage account. The data is accessible worldwide by a REST API over HTTP or HTTPS. It provides durable messaging queuing that keeps messages to be consumed at any time. Various applications store and retrieve messages from the queue and can be designed independently by decoupling them. It enables asynchronous communication between applications, whether they are located on premises or in the cloud. Various messaging services are available on Azure, such as Event Grid, Event Hubs, and Azure Relay. One of these, Azure Service Bus, supports message queuing but comes with different messaging features. It enables PubSub messaging via TCP protocols and transactions. Moreover, it ensures FIFO-order message delivery and manages message sessions to handle sequences of messages. Nonetheless, there is a queue size limitation of 80 GB. Queues can be integrated with event-driven architectures to process messages asynchronously in a queue walker, following a web queue walker architecture style. Additionally, queues can be used for processing large amounts of data, such as load files. Azure Queue Storage Client Libraries, .NET, Java, Android, C++, Node.js, PHP, Ruby, and Python. Without further details, let's go to the demo. Welcome everyone! Today we'll create a simple client-server application for sending and retrieving messages from Azure Queue Storage using .NET. So as a prerequisite, we need to have an active Azure subscription and then create a storage account. So define the project details, the subscription, the resource group, and the storage account name. So in this case will be Chris Code ST for storage account. Define the performance and redundancy. I will keep it simple with locally redundant storage. Click review and then click create. Go to Visual Studio, create a blank solution to create two projects. Define the name of the solution, Queue Storage. In the solution, we will add two projects, one for the client and one for the server. So add a new project, a console app, define the name, Queue Server with .NET 8, and the second project for the client side, Queue Server, okay, Queue Client, sorry. This is for the client. Now we need to add a NuGet package to connect with the Azure Queue Storage. Click Manage NuGet Packages and browse for Queue. This is the package we need to find out. Storage.queue, Azure.storage.queues. So add it to the project, install it, and then go to the program.cs file for the server side. We will create the queue and then send messages to the queue. We need to add the queue client to manage queues. So define a variable called queue client and instance the respective class from the NuGet package. We need to pass the connection string and the queue name. So let's define two properties, the queue name, queue1, and the connection string. Go to the Azure portal to get the connection string. Go to the storage account and scroll down to the access keys. Show the connection string and copy and then paste it here. Pass the arguments for the queue client, the connection string, and the queue name. How to create a queue? Let's print a message, creating queue, and use the queue client that create method to add the queue in storage account, and then we will send messages. So press enter to send messages. Console.read key. I will use a simple for statement to send 32 messages, which is the maximum value we can pick messages from the queue, from 1 to 32. The index, and then call queue client that send a message number passing the index from the for statement, and then print messages sent successfully. Console that read key to prevent closing the console window. And we've defined the program.cs file from the queue server. Let's go to the client side, which we will pick the messages and delete the queue to clean up resources. So let me copy the first 3 lines of code to use the queue client. Please don't do this in production, it's just for demo purposes. In this client project, we will pick the messages. So add a message, press enter to pick messages, console that read key, and then use this picked message model from Azure Storage Queues models namespace to store all the messages that we will receive from the queue client with the pick messages method, and specify the maximum number of messages we will pick. In this case, the maximum value is 32, and then use for each statement to print the messages. Okay, so how to do that? Use the queue client, use console that write line and message that body is the content of the message from the queue. That's it. And finally, we will delete the queue from the storage count to clean up resources. So print messages picked successfully, deleting the queue. Call queue client that delete method and console that read key. So far so good. We configured the client to pick messages and to delete the queue, and the server to send messages and to create the queue as well. So run multiple projects. So configure static projects, select run both projects at the same time, the client and the server, apply, go to the storage count and the queues tab. We don't have any queues yet, so far so good. Click start, it's creating the queue. So it says that specified resource name contains invalid characters, probably for the uppercase letter. So let me replace for Q1 the queue name, click start again. It's creating the queue. So far so good. Let's go to Azure portal, refresh the queues. We can see the new Q1, which doesn't contain any messages yet. So go to the server console window and press enter to send 32 messages. So far so good. Click refresh the queue. As you can see, we have all the messages into the queue. Let's go to the client side, press enter to pick messages. And as you can see, we have all the messages from the queue, and then we will delete the queue from the client side. Click refresh, and as you can see, the specified queue doesn't exist. Go to the storage count, go to the resource, and in the queues, it says that you don't have any queues. So far so good. What are the benefits of Azure Queue Storage? Flexibility. Queue Storage is fault tolerant when your application shuts down. Messages are buffered and remain available for processing by other applications. Scalability. It handles large volumes of data for high demanding applications, preventing servers from becoming overwhelmed. Distributed systems. Queues can be accessed anywhere, making it suitable for controlling applications in different regions. And the drawbacks. Message size. The maximum message size in a queue is 64 kilobytes. Message order. Queues are typically FIFO, first in, first out order, but multiple applications sending messages randomly can result in messages being out of order. No advanced features. It doesn't support duplicate detection and dead lettering messaging mechanisms. Limited querying. This service has limited querying and filtering capabilities compared to other messaging services.